So here are two circuits given. Let's call it A and this is B. So maybe I will use a different color. So this one, they two are essentially the same. We will see later, but first if we investigate circuit 1, we can see that there is no connection here. Actually this is separate, but there will be connection. So basically this is a voltage divider circuit, the first part. This voltage is divided between this resistance and this resistance, because the current becomes I equals to, so basically current is given there, so, or we can just write I equals to 380 divided by 75 plus 25, and that's I. So VAB, because this is terminal AB, AB, so VAB will be I times 25, given that we express I in milliamps, and because 25 is in kilo ohms, so if we keep I in milliamps and multiply by kilo ohms, we will get volts. But if we make I in amps, we have to multiply by 25,000, because we have to then convert this one to ohms as well, which I am not doing for the time being. So this one is there. So what we get here, instead of I, if we write like that, 75 plus 25 times 25. So this is the expression of the voltage divider circuit. And when we want to find AB, which is across 25, we multiply by 25. So basically the total voltage divided by sum of the resistances, whatever resistances are there connected in series, times the voltage across which we want to find the voltage. And when we do this one, we get 95 volts. So that's there. Now this one states if AB is connected to A prime B prime. So this one is also a voltage divider circuit, as we can see, 40 volts and 60 volts, 40 kilo ohms and 60 kilo ohms, and we want to get the output at V0, which is across 60 kilo ohms. So essentially VAB becomes VA prime B prime. So VA prime B prime is equal to VAB, and that is 95 volts. So that we know. So V0 becomes, now if we apply voltage divider rule directly, we get VA prime B prime divided by 40 kilo ohms plus 60 kilo ohms, and we multiply by 60. Now here again, even before, we didn't need to convert this into ohms, because this is a ratio. This is 25, the resistance divided by resistance. So even if we keep them in kilo ohms, both of them, it will be okay, because the unit is getting cancelled. It's just the ratio. 25,000 divided by 100,000 or 25 divided by 100 is the same. So that's why we didn't need to convert. You have to keep in mind, because otherwise, in order to get the right result, we have to convert kilo ohms into ohms, and then milliamps into amps, and so on. So again here, this is also a ratio, 60 divided by 100 or 60,000 divided by 100,000 is the same thing. So what we get, this is 95, this is 100, and this is times 60, so we get 57 volts. So that's fine, that's the result, V0. Now if we look at the second circuit, what happens here is there is a current controlled voltage source, and it says that basically we are trying to get the same result here, but we are trying to keep the input circuit and output circuit, we can say that. So this, or primary or secondary circuit, whatever, this side separate from that side, and so the current I goes through this like that. It's circling in the primary side, and a portion of that currents multiplied by 25,000 is taken as the voltage, input voltage here, or the secondary, or the source voltage of the secondary. Now why 25,000? Again, because the current here, these are all kilo ohms, and this is volts, so current will be essentially in milliamps. So when it's milliamps, it needs to be converted into amps actually, and then it needs to be multiplied by 25. So basically current, if we recall, current is the voltage VAB or VA prime B prime, let's say VA prime B prime, from the first circuit was I times 25. But there I wrote like that because I kept that in milliamps, but we should remember that it should be in amps actually, but I kept that in milliamps because I was multiplying by kilo ohms and you knew that it will work. But when you are designing a circuit, you should always remember that it should be actually milliamps. Basically I should have multiplied in the previous one also, I should have converted this into amps and then multiplied by 25,000, because I should have converted this into also ohms, but I was lazy anyway. So what actually should be the factor here is 25,000. So that's why this multiplication factor here is 25,000 times I, because that's what VAB is, VA prime B prime is, because like that. So I times 25, it should be actually I in amps, that's what it should be, times 25,000. But here I was in milliamps. So that was okay as long as I was careful, but this is how it should be. So that's why these whole secondary, instead of physical connection, there is a current control voltage source that's in the secondary, and that's value is 25,000 into, times I. So essentially we will get the same result. We can just check. So of course our I will be 380. Now I will calculate the I, which I didn't previously directly. So that was 75 plus 25, sorry, so that is 3.8 milliamps, or it should be 3.8 into 10 to the power minus 3 amps. So the secondary voltage now is actually 25,000 times this current, so that becomes 95 volts. So it's the same thing basically. So our V0 again becomes, now we get the same equation, V0 becomes 95 divided by 40 plus 60 times 60, and that is 57 volts. So the main reason of doing this problem is just seeing how these two circuits are essentially the same, but here in the second one these are separated and this direct connection is avoided by the use of a current controlled voltage source. And yeah, that's why if we could have used a voltage controlled voltage source as well, then it would be like, if it was this voltage, that would be that times just 1, because that's what it would be. So it would be just V not times 1, like that. So anyway,